In an industrial application, the number of general-use receptacles allowed on a 20-amp, 120-volt circuit is governed by the National Electrical Code, or NEC. The NEC aims to ensure electrical safety and prevent overloading of circuits, which can lead to overheating and potential fire hazards. The specific number of receptacles permitted on a circuit is determined by the load calculation for each receptacle. The NEC provides guidelines for these calculations to ensure that the total load does not exceed the circuit's capacity. In the case of general-use receptacles, the NEC typically assigns a load value of 180 volt-amps per receptacle. This value represents the assumed load that a typical device plugged into the receptacle might draw. To determine the maximum number of receptacles allowed, you divide the total circuit capacity in volt-amps by the volt-amp load per receptacle. For a 20-amp, 120-volt circuit, the total circuit capacity is calculated as 20 amps multiplied by 120 volts, which equals 2400 volt-amps. Now, divide the total circuit capacity of 2400 volt-amps by the assumed load of 180 volt-amps per receptacle. 2400 divided by 180 is approximately 13.33. Since you cannot install a fraction of a receptacle, you must round down to the nearest whole number. This calculation suggests that you could theoretically install 13 receptacles on a 20-amp, 120-volt circuit based on the 180-volt amp per receptacle rule. However, it is important to note that the NEC specifies that for non-dwelling units, which includes industrial applications, a load of 180 volt-amps is required for each receptacle. Therefore, with a 20-amp, 120-volt circuit providing 2400 volt-amps, dividing 2400 by 180 results in 13.33. Thus, a maximum of 13 receptacles is permitted in the circuit. However, other factors can reduce this number. Firstly, consider the type of loads that will be connected to the receptacles. If specific equipment is known to draw a higher or continuous load, the circuit capacity needs to be adjusted accordingly. For instance, if one or more receptacles are intended for specific equipment with a known load, that load must be subtracted from the total circuit capacity before calculating the number of remaining receptacles. Secondly, dedicated circuits may be required for certain types of equipment. The NEC mandates dedicated circuits for specific appliances or equipment to prevent overloading and ensure proper operation. For example, large motors, heating appliances, or sensitive electronic equipment often require dedicated circuits. Thirdly, consider the potential for future expansion or changes in the industrial facility. It is good practice to leave some capacity in the electrical system for future needs. Overloading circuits can lead to frequent tripping of circuit breakers, equipment malfunction, and potential safety hazards. Therefore, it is important to design the electrical system with sufficient capacity to accommodate future growth. Fourthly, the NEC also addresses the spacing and location of receptacles. The code specifies the maximum distance between receptacles to ensure convenient access and prevent the use of extension cords, which can pose safety risks. The specific requirements for receptacle spacing depend on the type of occupancy and the wall length. Fifthly, in some industrial settings, specific types of receptacles may be required based on the environment. For example, in damp or wet locations, ground fault circuit interrupter, or GFCI receptacles are required to protect against electrical shock. Similarly, in hazardous locations, explosion-proof receptacles are necessary to prevent ignition of flammable substances. Sixthly, it is crucial to follow all applicable electrical codes and regulations, including local amendments or interpretations of the NEC. Electrical codes are designed to protect people and property from electrical hazards, and compliance with these codes is essential. Seventhly, consulting with a qualified electrical engineer or licensed electrician is highly recommended when designing or modifying electrical systems in industrial facilities. These professionals have the knowledge and experience to ensure that the electrical system meets all the applicable codes and safety standards. Eighthly, it is also important to consider voltage drop in the circuit. Voltage drop occurs when the voltage of the receptacle is lower than the source voltage due to the resistance of the wires. Excessive voltage drop can cause equipment malfunction and reduce efficiency. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. Ninthly, the type of wiring method used can also affect the number of receptacles allowed on a circuit. Different wiring methods have different ampacity ratings, which is the maximum current a conductor can carry safely. The ampacity of the wire must be sufficient to handle the load of all the receptacles in the circuit. Tenthly, always consider the cumulative load and power factor. The cumulative load is the sum of all the loads connected to the circuit. The power factor is a measure of how efficiently electrical power is used. A low power factor can increase the current draw in the circuit, which can reduce the number of receptacles that can be safely connected. In summary, while the calculation based on the 180 volt ampere receptacle rule might suggest a higher number, a more conservative approach is generally recommended in industrial settings. Considering the potential for higher loads, dedicated circuits, feature expansion, and other factors, limiting the number of general use receptacles on a 20 amp, 120 volt circuit to 10 provides a margin of safety and ensures reliable operation of the electrical system. Moreover, the NEC provides detailed guidelines and requirements for electrical installations in industrial facilities. Adherence to these codes is essential for ensuring electrical safety and preventing hazards. Always consult the latest edition of the NEC and any applicable local codes before designing or modifying electrical systems. It is also highly recommended to engage a qualified electrical engineer or licensed electrician to ensure compliance with all applicable codes and safety standards. They can perform load calculations, select appropriate wiring methods, and ensure that the electrical system is designed and installed safely and efficiently. In addition, regular inspection and maintenance of electrical systems are crucial for identifying and addressing potential problems before they lead to equipment failure or safety hazards. This includes inspecting receptacles, wiring, and circuit breakers for signs of damage or wear, and testing GFCI receptacles to ensure they are functioning properly. Furthermore, proper training for employees who work with or around electrical equipment is essential. Employees should be trained to recognize electrical hazards, follow safe work practices, and use personal protective equipment appropriately. This helps to prevent accidents and injuries related to electrical work. Finally, it is important to keep accurate records of electrical system modifications, inspections, and maintenance activities. These records can be helpful for troubleshooting problems, planning future upgrades, and demonstrating compliance with regulatory requirements. Remember, the electrical system is a critical part of any industrial facility, and its safe and reliable operation is essential for productivity and safety. By following the NEC guidelines, consulting with qualified professionals, and implementing proper maintenance and training programs, you can ensure that the electrical system meets the needs of the facility while protecting people and property from electrical hazards. While the theoretical maximum might be high based on simple calculations, practical considerations and safety margins often dictate a lower number. 10 receptacles on a 20 amp, 120 volt circuit provides a reasonable balance between convenience and safety in many industrial applications. However, always prioritize safety and consult with qualified professionals to ensure that the electrical system meets the specific needs of your facility. Also consider the specific needs of the equipment being powered. If certain equipment requires more power, fewer receptacles should be installed. Consider that some equipment may require a dedicated circuit. High-powered equipment is safer when isolated to their own circuits. If there is potential for expansion, reduce the number of receptacles to allow for additional equipment. Consider local and national codes. Codes are always changing. Consult with a licensed professional when making changes to ensure that your system remains in compliance. Always prioritize safety when installing and maintaining electrical systems. Electricity can be dangerous if not handled properly. Be aware of potential hazards and take steps to mitigate them.